In this video, we're going to be solving systems of equations by substitution. So first, let's look at what we have. So here we have a quadratic, and here we have a linear function. I know this is a quadratic because this is square. So if I want to do solving systems of equations by substitution, we can see that both of these are equal to y. So that means this y equals this y. So I can simply set the equations equal to each other. So that means I'm going to take my quadratic, negative 3/4 x squared minus 4x, and I'm going to set it equal to 3x plus 8. Because basically these y's are the same, which means that these are also equal to each other. Because I can substitute in 3x plus 8 for y. So that's what I did right here. So now I'm going to solve by making this equal to 0, because I want to find the zeros because I have a quadratic. So I'm going to move all of my terms over to the right side so I'll have positive values. So first let's get this 4x over to the right side, and then that gives me negative 3/4 x squared is equal to 7x plus 8. And then I'm going to add 3/4 x squared to both sides of that equal sign. And then I get 0 is equal to 3/4 x squared plus 7x plus 8. So now you may be looking at that and thinking, yeah, I don't really want to factor that. I don't know how to factor that because I have this coefficient of 3/4 there in the front. So a little trick that you can do with this is you can multiply everything by 4. Because I want to get 4 out of the denominator. As long as I'm doing it to both sides of the equation, I'm good. So I know that 4 times 0 is 0. And I know that 4 times 3/4 x squared simply gives me 3x squared. And 4 times 7x, that gives me 28. And then 4 times 8, so that gives me a positive 32. So I'm going to look see if I have a greatest common factor, and the answer is there is none. So then that means I'm going to go straight to my factoring, and this should look very familiar by now. So I'm going to do 3x squared times 32, and that means I'm going to get 96x squared, and my 28x is here in the middle. So I'm going to look for my factors of 96x squared that add up to 28, and that ends up being 4x and 24x. So if you remember from past factoring videos that I'm just simply using that to replace my center term. So all of this should look very much familiar to what you've done. So this is going to be plus 4x plus 24x plus 32. Now I can split this into two parts. So common factor here is going to be x. So I know that this is going to be equal to 0. So I'm not going to worry about this right now. That might get a little visually confusing. I'll put that in at the very end. So I factor out my x. So 3x squared divided by x gives me 3x. 4x divided by x gives me 4. Common factor here is going to be 8. And that's positive. So that's going to be a plus 8. And then when I divide, that gives me 3x plus 4. So I can see here that I have a common factor of 3x plus 4. So I can divide out my 3x by 3x plus 4. and that means that I have 3x plus 4 times, this turns into a 1, this turns into a 1, so then I'm left with x plus 8. So that means, remember, 0 equals. Where'd that 0 equals come from? Well, that's what I started with right here, so I just bring that down. So now that means I'm going to set each of my factors equal to 0. So I'm going to have 3x plus 4 equal to 0, and x plus 8 equal to 0. So this one's pretty straightforward. That means x is going to be negative 8. And here, this means if I subtract 4 from both sides, and then I have 3x equals negative 4, and I divide both sides by 3, I end up getting x is negative 4/3. But I'm not done, because in the system, I'm looking for the intersection of these two functions. And in fact, if I were to graph it, my top function would look like this. That's my quadratic. And this bottom function would look like this. So in my system, my solution is here and here. They're points, and they have an xy coordinate value. So I found the x's, now I have to find the y's. So the easiest way to find the y is to substitute x back into the easiest equation, which would be our linear one. So now I'm going to solve for the y. So my linear equation was y is equal to 3x plus 8. So I'm going to substitute this in, and I have to keep them straight to know which x give me which y. So here I'm going to substitute in negative 4/3. So this means y is equal to 3 times negative 4/3 plus 8. 3 divided by 3 is 1. So I have negative 4 plus 8. So that means then that y gives me 4. So then I know that that one coordinate for this x is going to be negative 4/3 comma 4. So this here is one solution. And then I have to do the same thing for my negative 8. So I'm just going to use the same linear equation because that's easy. So y is equal to 3 times negative 8 plus 8. So that means that y is equal to negative 24 plus 8. So then y equals negative 16. So this y went with this x. So my other solution is negative 8, negative 16. So that's my second solution. The intersections of the two functions.